All right, hey Kels, this is 10-3 stuff, and then our equations weren't working, so I'm gonna kind of regroup today. We're gonna do number 4 in your homework assignment together, and then I've made a deal with them. You don't have to do number 3 at all. You can cross that off on homework, but I said I made them a deal. If things go well, then you can cross off number 5 as well. So number 4, Marcus has already typed in and he has given me an equation for this list. Let's talk about what we're doing first though. We're talking about altitude and temperature. Okay, the higher up you are on the mountain, typically what happens?
The lower altitude.
That's higher the altitude. The higher the altitude, the
lower the pressure.
The lower the temperature. We're talking about temperature here. So high at all. And our temperature is 58 degrees. Then we go all the way down to negative 53 degrees because we're at an altitude of 32,000 feet, right?
True. You're right.
32,000 feet is like, I don't know. I'm pretty sure altitude is in thousands of feet. So 32,000 feet would be like 6 miles in the air from sea level. From sea level, right? Okay. So that's how that works. The temperature is going down, etc. Okay. All right, and we're doing a flight. Usually flights like that's it. That's 6 miles in the air. That's pretty high.
I swear.
All right, so and if you go on an international plane, they have like a screen like that you can watch movies on, but one of the channels is like the temperature that it is outside your window.
Regular planes have that too.
What?
Regular planes have that too. The American Airlines one.
Okay, well, I don't. You agree, Southwest?
No, they're so
Two bag check.
No.
There you go. All right, go. Y equals. Y hat equals.
Negative 3.63x. Plus 70.6.
70.6. Okay, that's the regression equation that Marcus has typed in. And there is that. All right? Put that on your sheet of paper under number 4. Okay? We need to know what y hat is. Okay? Now, y hat has this equation, but like we need to know what the y value would be. Are you listening? We need to know what the y value would be. So 2 corresponds to 58, but what should come in? If we plug 2 into there, what should the temperature be according to what the equation is?
58.
No. What's your y hat value? What should that number be? Okay? Somebody else plug in 9. Somebody else plug in 17. Somebody else plug in 19. Somebody else plug in 29 into this equation. Tell me what those values should be. The faster you go, the faster we get done.
2 is 63.34.
63 point, we'll just go 3. Okay? 1 decimal place.
37.93.
37.93. 17. Anybody got 17 or 19? Anybody got?
8.89.
You got what? What?
8.89 is 17.
8.89.
19 is 1.63.
We'll go 8.9. I didn't do 19 was
1.63.
1.63. Okay.
Then 29.
Yep.
Negative 34.7.
Okay. Go 41.9. Okay.
And then negative 45.6.
Negative 45.6. Okay, so those numbers aren't off too much from what they should be, right? In fact, some of them are really close. Like the 31 was pretty close. 45 point. What was that last one? 6. Okay, my thing glitched out. Okay, so according to the equation, the regression equation that it spit out, those are the values that they figure out what the error is. It is saying use a 95% confidence level with an altitude of 6,327, which they're saying is 6.327. See, that goes between 2 and 9. So what we're trying to do is we're trying to figure out what the temperature would be. We're trying to figure out what y should be, but we don't want to like give just a definitive value. We want to give a range. So we have to figure out like the y hat minus the error and the y hat plus the error. Got it? Okay? So we need to first and foremost actually figure out what y hat is for 6.327. Okay? So like if this is the x coordinate, what would the y hat coordinate be, and how do you find that? Plug it in like we just did, right? So plug in 6.325 or 327 like we just did. What should the temperature be? Somewhere between 63 and 37. What?
47.6.
47.6. Okay, so we're going to take 47.6. We're going to figure out what the error is. We're going to add and subtract it. That's all. Okay? So rather than me saying definitively, it will be exactly 47.6 degrees at an altitude of 63 this, right? Okay? All right, and that's when we have to calculate our standard error and our regular error. Oh, this is the sum. Isn't there a sum in front of that? The sum of all the y minus y hats? Help me out here. We have to do y minus y hat. That's the first thing we have to do for our calculations. Okay, y is 58, y, somebody give me that answer. 58 minus 63.3 and squared. Minus this squared. This guy minus this squared. Okay, so subtract them, then square it. Subtract them and square it. Subtract them and square it. Anybody have our first ones?
28.09.
28.09. Okay, 40 minus 37.9 should be like 9 point something or something, I don't know. Subtract these two and square. Subtract these two and square.
I got the 1.6 is 73.96.
73, 23, 1. 23 and 8.9.
198.8.
198.8. Okay. Alright, next. Those guys subtracted and squared. So like 4.7 squared really is what it is. Something like, I don't know, 20 maybe.
22.1.
Or like, was it 0.81?
Yeah.
0.81? Perfect. Okay, these two subtracted, squared.
54.8.
54.8. Okay. Alright, so there's that. Okay, now we need the sum of all of those for this top number. So, somebody add those all together. Okay, somebody else figure out what n is. N is how much? Alright, what's our top number? All of those added together. Like in the,
3.01.
what?
The total is 383.
383? 383.
That's what I got.
0.01?
Yep.
Okay, perfect. Alright, so, 5.
171.3.
Are you sure?
Yes,
I don't think you're right.
I plugged it in.
5 first, before you took the square root? What?
8.75.
That sounds better. I
Yeah,
think
that-
yours is just taking the square root of 383 and then taking that number divided by 5. We wanted to divide by 5 before it takes the square root.
I got
Probably
what?
why.
That's probably,
I probably messed up.
Sarah sounds better. So take 383.01 divided by 5, then the square root of that. Tell me what you get for standard error.
Oh, I know why, because I took the 383 square.
Yeah, we already squared all. What? 8.75 like what Sarah got? Okay. Alright, 8.75, perfect. Okay. Alright, oh, we don't have a t value. We need 95% and the freedom.
2.447.
2.447? 2.447, and now we've got our standard error, which is 8.75 times, we got a square root of a whole bunch of junk. Holy bejeez, that's a lot of stuff. Okay, alright, but these should be like not too bad. Where for my n? Square root. 7, 7, 7. Alright, what's x0?
70.6.
No.
Okay, just kidding.
X0 is the x that I have.
Oh, negative 3.63.
No.
Okay. In the
2,
equation
7.
then.
Minus, what?
What's the thing in the equation?
What you talking about?
The regression equation, I thought.
That's y hat.
Wait.
That's the y value.
Oh,
All the x's. Should be something like in the 20s maybe. So take these x's and add them all together. And divide by 7. X bar. Somebody add those all together and divide by 7.
19.9.
19.9, that sounds good. Okay? Alright. Is somebody doing this whole big,
Yeah.
Yeah.
okay. Yuck, yuck. This is a lot. 2 squared is 4. 19 squared is, I lost track. Somebody do. 19 squared. We got a lot of people with calculators that are not using them. 19 squared. Do it.
Big.
361. Okay. 29 squared.
841.
841. Okay. 31 squared. Somebody be adding these together.
960. 1024.
1024. Okay. Now somebody add 4 and 81 and these black numbers together. 3561. Okay. Minus, okay, how is that different than the sum of the x's squared? So you add all these x's, so 2 and 9 and 17 and 19 and 29 and 31 and 32 added together, that number squared. Somebody want to do that for me? We're getting close. So add those, all those numbers together.
On the test.
and square.
Yeah, is there gonna be just like one?
Is anybody
of
figuring
these
it out?
My
answers?
blood was sent to
Why does she
Houston
do that? She does that all the
Methodist,
time. She just.
the Woodlands Hospital.
How do you play? I'm not gonna just tell you.
I'll look
Let me
up
get
and
it?
do that.
I
The
did.
sum of all of them
You do it
squared.
193.21
After you square or before?
after a square.
193.1, 321.
What's
Got
the
it.
three number? What's
Alright,
the?
we don't have to
Do
square
it.
that number?
That's
No.
already squared.
Alright, answer. 25.1.
Are you sure you typed it in correctly?
Yes.
I got
You took-
25.1.
Fine, write that really big. That's E.
That's wild.
That is E. That's a big E. 25 degrees is the error. Okay, we're almost done. We gotta find the range, okay? So, according to the 6,200 feet, an error of 25.1 degrees. So that means it's gonna be between something and something. Add and subtract.
22.5 and 72.7.
And 72.7. Wow, that really narrows it down for
I would
me.
say we paid attention really
To
big.
do it as a range like that, true?
True.
Like that, I'm like 47.6 would have told me better than temperature. I at least know the temperature's probably not going to be negative at that altitude, right? Okay, but that's still a pretty wide range. Why is that range so big?
Almost
I
7.
forgot so.
We only have 7. It's only doing 7,
Less to add.
less to add, correct? So like, there's drawbacks and there's benefits. Yeah, we don't have to do as many calculations. Okay, so that's what we give and take, right? Okay, so there should be, with 95% confidence, I'm 95% confident that the temperature should be between that and that, right? That is what we just found. Great. Okay, go to the notes real quick. You have one example left to do, and it is talk about the back page of the notes, just real briefly. I'm going to skip over some things. Everybody give me your attention. Emma, are you listening?
Yeah.
You need to listen. All right, here's the deal. Okay? Look at this chart right here. This is my regression equation. And I have the dot 5 comma 13 that lives on that line. Do you see that where that dot lives right there? Boop. Okay, there he is. Now, if I plug in and I do the like y hat value, like what it should be, or actually if I do y bar, I think y bar is the average of the y's. Yeah, if I average all the y's together, all of these y values, all of these y coordinates average out to be 9. So they've drawn a line right here and they say, like, that is my line right there, okay? Now, we have something that's called explained variation and unexplained variation, okay? So, like, obviously every dot is not going to lie on this regression line. There's going to be some that, like, are outliers that are all the way up here, like at 5 comma 19, okay? Now, here's the deal. Any value that lives between the average of the x's and the regression line is going to be explained. Like, that makes sense that that would be a dot that would live in there, right? Between the average and what the regression line. So if it lives in here, in any of this space right here, that's going to be like explained variation. Like, that makes sense that that would be there. Versus if we have dots that live completely outside the regression line, like not even close to average, this is going to be unexplained. Like, this doesn't make any sense at all, meaning that he is probably an outlier. Does that make sense? So we have explained variation is the area between average. This is the average value for that line, right? And the regression line, which is what the calculator spit out for me. If I have a coordinate that lives anywhere between those guys, that makes sense for it to live there. But if I have a dot that lives outside of there, it's probably an outlier, and it's like a number in my data set that just does not make any sense. Correct? That's explained versus unexplained. Okay. Now, I'm going to skip this total deviation, whatever total variation stuff. Let's go down to here. This is what your homework assignment asks a question on. This is what your homework assignment asks a question. Okay? You know how we've had like an R value before, right? Like it spits out an R.
Yes.
What does R live between?
Q and R.
I did.
You're on 1.
What?
You're on 1.
Close.
I was gonna say -1 and 1.
Negative 1 and 1, right? And 0 lives in the middle. Okay. So this is the range of where R lives. Okay. What's considered to be good for an R?
99, 1.
anything over here or anything over here, right? If it's close to 0, that's bad. That's a bad R. Like if they say the R value is like 0.1, you're going to be like, that is not linear. It's like all those dots are all over the place. So a good R is anything close to 1 or -1. Okay? That's what R is. Now, the R squared value, if I simply take this guy and square it, are you ready for this?
Oh no.
If I simply take that guy and square it, that tells me the equals the percent of data that is explained. Okay, the percent of data that is explained by your equation. Okay, so this is how the R value is split up. Ready? You know, I told you about this region right here. If you have any data points that live in here or in here, that's explained data. That's data that makes sense. If I have data that lives outside of here, it doesn't make sense. Those are outliers. So your R squared value tells you the percentage of data that lives in here and in here. Does that make sense? In that range of data that should be there, right? Otherwise, everything else, if you have data points here and data points here, that's unexplained, okay? So if the R squared, let's say the R value is 0.9, right? R value is 0.9. What would R squared be? 0.81 if I square it, right? That means 81% of my data, are you listening to this?
Yes.
If R is 0.9, R squared is 0.81 because you square it, okay? That means 81% of my data is living here and here in the explained region, okay? Versus like these dots that are like outliers that do not make sense, okay? Good? Yes? Okay, so it's explained variation versus total variation. The range that is like that makes sense for those dots to be living there, right? Versus the total variation, which is all of the stuff all over the place. Okay, so here we go. Example 2. If we use 23 pairs of chocolate data, which is 23 for N, which I don't think we need, but we're going to write it down. It says that the correlation coefficient for R is 0.801. Find the coefficient of determination. So the coefficient of determination, I'm just going to call it CD. What is that thing again?
R squared.
R squared. Okay, what will R squared be?
A number.
What?
0.801.
0.64.
Two.
What? 2? Okay, 0.642. That's what the R squared, that's the coefficient of determination. You just take the R and square it, right?
Yep.
Okay, also find the percentage of total variation that is explained.
Move the decimal.
Move the decimal. So what's my percentage?
64.2.
64.2% of that data is making sense in there. It is explained by the linear correlation, right? 64% of my data is basically linear. The rest of it is not. Okay? Make sense? So is 0.8 a good R in this case?
No.
If it boils down to 64% is making sense, I don't think that's necessarily a good R. I mean, like, I wouldn't pick it, right? 0.8, I mean, it's decently high, but I don't think that's real great.
I go to the restroom.
Okay, good? All right, so number 2, that's all you have to do for homework. Good?
Yeah.
Yes? All right, there you go. Goodbye.
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 Bye-bye.
Goodbye, Kels.